Hello. Today we're going to be talking about expressions and equations. And more specifically, we'll get to solving equations. But first, I want to talk a little bit about what's the difference between expressions and equations. And that's equations have equal signs. Expressions do not. And so if you have an expression, I want you to know that you can translate this to English. Or something in English can be translated into an expression. So here's just a couple quick examples. If I read it in English as 7 less than a number, you can write that as n minus 7. 3 times the square of a number, 3 times the square of a number being an x, a variable, you've got 3x squared. The cube of a number increased by 4 times the same number. In fact, it's very helpful when they get long to put lots of spaces in between each word, soak up each word. So the cube of, so if I have some value, I raise it to the 3rd power. Increased by, increased means adding. Suppose the cube of, there we go. 4 times, well, take a 4 and then times it by that same number. That same number, what letter did we use before? We used P. So P to the 3 plus 4P. It's another way of writing it. Notice how algebraic is a shorter way of writing it. Next, we have twice the sum of a number and 5. So if I'm looking at twice, that's really 2 times something. That's 2 times something. Now, something is what? It's the sum. The sum means we're adding. So we're going to have a plus of something that we're going to multiply it times 2, which means there's going to be a group of something. And so what are those things? A number, well, if we see a number, come up with a variable. How about y? And 5. So that's the other number that we're going to be summing. We're going to be adding. So English to algebraic, can you translate from one to the other? So think about this. What kind of words represent addition, subtraction, multiply, divide? Well, when we think about adding, those are words like more, plus, increased by, or the sum of. And generally there's going to be a blank and a blank. When we talk subtracting, that's another word is minus, or decreased by, or difference of, or less than. Multiply is product of, times, twice. Divide, quite often, we'll see a quotient of. There isn't a whole lot for dividing. The next thing I want to remind you of are what you learned in geometry. Here's a few properties that we have. And so we've got the reflexive property. In other words, one value is exactly equal to itself. So in other words, one side of the equation equals the exact same thing on the other side of the equation. That's a reflexive property in algebra. The symmetric says, okay, well, if A equals B, then I should be able to turn it around and put the B first. So B would have to then equal A. So if 3 equals 5x minus 6, you should be able to flip them around and write 5x minus 6 has to equal the exact same thing as a 3. That's your symmetric property. A lot of times we don't think of these as actual properties, but they are. The transitive property gives us 3 values. So if A equals B, but B is also equal to C, well then the A and the C also have to be equal to each other because they're both equal to B. So if 2x plus 1 equals 7, and 7 also happens to equal to 5x minus 8, then we should be able to take the first one, which was 2x plus 1, and set it equal to 5x minus 8. So remember, transitive property. And last, substitution. If A and B are equal, then you can replace A with a B. In other words, if I have a 4 plus 5, and we know that that equals 9, then I should be able to just replace that 4 plus 5 with the 9. In fact, we commonly just zip right through this and don't even realize we're doing substitution. Here's the property that gives us the most power for solving for variables, and it's called properties of equality. And properties of equality say that you can add anything you want to an equation as long as you do it to the exact same thing to both sides. So if A and B are equal, I can add C to both of them, and my equation will stay equal. So if I have an x minus 4 and it equals 5, well, what if I want to get rid of this? Now here's where we can use this to our advantage. If I have an x minus 4, then I know that if I plus 4 to it, guess what? It's going to cancel out that minus 4, and this whole thing will leave only an x. And so then, what's going to be on the equal side? Well, then we'll have to say that 5 plus 4 equals just that 9. And then we can check it by saying, hey, does 9 actually minus 4 equal 5? Yeah, it does. And so we can do this with both addition and subtraction. If I have an n plus 3, then what's the opposite? Well, let's minus 3, but if I minus 3 to the left side, I have to minus 3 to the right side, and these cancel out, leaving n all by itself equaling 11 minus 3 more is minus 14. That can get us so that our goal is to get what is just the variable. Not our variable plus 3, but what is just that variable. Same property works with multiplication and division. In fact, you're doing both just the opposite. So the only catch here is that whatever you multiply or divide, it can't be 0 because you can't go back. You'll get undefineds. It's messy. So if I have an m over 4, when we see this m over 4, that's actually a divide. And so what you want to do to both sides is you want to times it by 4. Times 4 here, but then I'm going to have to times by 4 on the other side of that equation. We know that the 4 divided by 4 equals 1. 1 times m is just a plain old m. And then we can solve it. We can say, hey, guess what? M is going to equal 24 because 4 times 6 is 24. If I have something multiplied like this negative 3y equals 6, then what is the opposite? Well, if this is a negative 3 times y, then the opposite of that would be divide by negative 3. And we can write it as a fraction because fractions are really just division problems. So what I do to the left side has to be done to the right side. And guess what? A negative divided by a negative makes a positive. 3 divided by 3 is a 1. And all you're left with is just a plain old y equals, and then we can figure out what it is. 6 divided by a negative 3 is a negative 2. So here's your list. And write these down, because with this list, you can solve any equation. Any equation, no matter how big it is, if you follow these 4 steps, using the properties of equality, the distributive property, you can solve anything. So first, look, are there parentheses that's giving it? So let's first clear those. Let's distribute it. A 2 times each of those is going to give us a 4x plus a 6 minus, again, we got more parentheses, so let's distribute the 3 to both of those. And remember, we have a minus 3 being distributed. So it's going to be a negative 12x, but a negative times a minus 5 is going to be a positive 15. That's an easy one to miss, is this positive right here. We know it's going to be equal 22 because all we did really is just distribute. Second, if you have any like terms, combine them. Like terms were items like this, 4x and minus 12x. If I have 4x and I take away 12x, I'm going to be in the hole about 8 x's. Also, if plus 6, that's just a plain number, and plus 15, well, can I put those together too? Why not? They're like terms. So that's 21. And guess what? That still equals 22. We're just simplifying it. We're making it a little bit simpler. After this, now again, pay attention to this order. Third, the order matters. Undo any addition or subtraction happening to your variable. So if my variable's right here is this x, what's being added or subtracted to it? It's this 21. So we're going to do the opposite of what we see here. The opposite of adding 21 is we're going to subtract 21 to both sides. So if I subtract it on the left, I need to subtract it on the right, 21 on both sides. And if you like writing it below it, I think it's a little bit simpler. That means the minus 8x will still be there, but a plus 21 and a minus 21 equals 0. A plus 0 you don't necessarily have to write. And then it'll equal 22 minus 21. Well, we know that's just going to be a simple 1. The last step, and it's always undo your multiplication or division. You're always either going to be multiplying or dividing last. So to do that, we're going to say if that's a negative 8 times x, we're going to divide by that same negative 8. But if I do it on the left, I have to do it on the right to keep this thing balanced. So a negative divided by a negative is positive, and 8 divided by 8 is 1. X is the only thing left, and that was our entire goal right there. Now here's the deal with some of these divisions. 1 doesn't divide by a negative 8 very nicely, and so instead of getting a decimal, please don't get a decimal. Leave it as a fraction. In fact, you don't even need a calculator to do this because the fraction that's left is simply a negative 1 over 8. And so x is negative 1/8, and that is your final answer. And so by following these 4 steps, you can solve any equation. You can solve for any variable. Again, have these steps written down. Pause if need be so you can write down. But that will lead you to every answer as long as you follow that order. And even if you don't know all the numbers and you can't actually perform the operation, so if you had an s equals pi r L plus pi r squared, oh my goodness, what if I just want to solve for L? Well, first thing, let's minus pi r squared. And if I do it to one side, I have to do it to the other. Notice these two are going to cancel out, and you're just simply left with pi r L. Okay, well, I can't combine s minus pi r, but guess what? Just leave it there. Just write it. It's okay. Then if I wanted to get L by itself, divide by, what do I need to divide by? Whatever I want to get rid of. I want to get rid of that pi and r. So the pi is going to cancel the pi, the r is going to cancel the r. L will be the only thing left. But what you do on the right side has to be done on the left. And so to simplify it, even though we can't divide by all these blanks, all these spaces, we don't know what these variables are, that's okay. Leave it written just that way. We're just simplifying. The hardest part is seeing it without numbers because our brain wants to do some operations. But when it's all variables, we can't. So just copy it and copy it down. That's the trick. Hopefully this helps. Good luck. Have a great day.